Great.
Yeah, great. So good afternoon, Mr. Abhishek Kant, and good afternoon, dear participants. Today, I'm going to hand over the platform to Mr. Abhishek Kant, who is basically an engineer, and then he is a management graduate as well. So I remember that when he passed out, he was picked up by Microsoft, the then best company in ICT on the planet. And I still remember that he had been invited to Redmond, the headquarters of Microsoft, to deliver a lecture. I had seen him quite often on various media platforms, and I had also seen him delivering live on TV shows, which used to be at the pinnacle those days. Now, of course, it has gone to number 2. And after that, Mr. Kant found that the experience of Microsoft should be disseminated to the people across the globe without having any, sort of limitation or being in a frame of Microsoft. Then he moved to a company and he became the CEO of that company. And the name of the company is so fresh, it was GTM Catalyst Private Limited. But that limited word, he started working on him again. And then he found that he is duty bound to work as CEO more like a bureaucrat and less as a person who is having the knowledge. So I don't know how could I catch hold of him, maybe because of the personal rapport that I had with him, that he agreed. He is a very busy person. Luckily, I could catch hold of him for about an hour. So friends, I don't want to waste your time and the time of Mr. Kant. So we'll be talking about the interrelatedness of deep learning, machine learning, and the resultant artificial intelligence and things like that. So friends, the platform is over to Mr. Kant and to you. And as per the rule, we agreed this morning that as long as he is delivering, then we will not disturb him. Once he is through, then of course, I'll invite everybody to ask a number of questions. Thank you so much, Mr. Kant. The platform is all yours.
All right. Thank you so much, Mr. Pandey. I appreciate the opportunity to be able to present my learning on the interrelatedness of artificial intelligence, machine learning, and all the associated aspects of the technology. What I'd like to do is probably bring out a presentation I have prepared. So may I request that screen sharing be enabled for me, if you don't mind. I see a message that says host has disabled participant screen sharing, so you would probably need to enable that for me. All right, thank you. You can see that it's being shared now, so let me share the screen, hopefully. All right, great. Thank you so much. So welcome everyone once again. I think it has gone the other way around. Just a second. All right. Second. Okay. So what you see here is the topic that I was presented with. Interrelatedness of deep learning, machine learning, and artificial intelligence. Now, what better way to get started than to show you such a system already in action? Now, you see the subtitles that are going along with whatever I'm speaking. And obviously, you can judge the accuracy of these subtitles by themselves. Now, this has been enabled. Now, the subtitle system has been existing for a long time. But what you see here is the accuracy, which is almost, I would say, human-like. If a human had to do this manually, what you see here is what's going on with the help of machine learning, or I would say artificial intelligence in the background. So I just wanted to get started with giving you a very simple application of artificial intelligence in a very, very relevant context. Now, people may come with different accents, they may come with different terminologies. It's great to have something represented in textual format as the speaker is also delivering his speech. So that's what you see here in use. Well, this is me. Dr. Pandey has already introduced me quite graciously. Here is a little bit about myself. I have about 20 years of experience in technology. I was working with Microsoft for over 10 years, initially in Seattle, then came to India for a few years that I worked. I then worked with another database and an intelligence technology or a AI company called as Progress, data and AI company. I have been delivering sessions on AI and such for a long, long time now. And obviously my interests would include cloud computing, artificial intelligence, of course, finance and investing as well. I've been speaker at various locations, as you can see, NASSCOM, Microsoft Tech and stuff like that. My email ID is mentioned right up there in case you need to get in touch with me for any purpose. Please feel free to note that down. As Dr. Pandey had said, I'm currently running my own company, which is gtmcatalyst.com, or you can find more details on gtmcatalyst.com. And we undertake data and AI work for various organizations across the globe. So that's what it is. Some of my certifications are mentioned here to further detail my credentials. Well, of course, by education, as Dr. Pandey has already mentioned, I am an engineer with a management degree as well. So I put the agenda together, very simple introduction to artificial intelligence and the interrelatedness of it all. But then I also wanted to talk about a very important aspect of artificial intelligence, which is responsible AI. While artificial intelligence is all around us all the time, and this is what is now being called the oil of data. So how artificial intelligence improves data usage and it builds intelligence into it. But as we are building intelligence into data, how do we make sure that we're doing it responsibly? And what are some of the considerations we want to think about when we are thinking about responsible AI? What is also quite crucial is most of the aspects of responsible AI revolve around the human aspects. Hence, I think very relevant for our discussion again today. Well, very quickly, what is the artificial intelligence? But before I get there, let's see how it all began. Well, it began from a very simple analytics space. For a long time, we've been doing analytics. We've been building summaries, trends. We've taken all that historical data and we've drawn that up. And we've seen all these charts from time to time, whether it is recruitment numbers, whether what is the SAT scores across the number of years, what is that net NSAT or whatever, net satisfaction scores for the employees, what's been the attrition rate. We've seen all these graphs being put across for a lot of these years. This is where it all began. The analytical, we call this the analytical workload. And this is where we look at historical data and try to think about what was the trend based on this historical data. So this is what we call as the analytical workloads. While all the intelligence or all the trends that we could decipher in the analytical workloads, artificial intelligence takes it to the next level. Simply put, if I pick up a pen and have to draw what the analytical workload is and then map it down to where we are today, and if this is the timeline, this is where we are today. When we look at the past, this is where analytics comes in. We are looking at pasts. We are looking at 2020. We are looking at, 2021. We are looking at 2020. We are looking at 2019 and trying to build up a graph on whatever is happening. So if T is 2022. Now, where AI comes into play is AI is all about the future. AI is about figuring out what's going to happen in 23, what's going to happen in 24, what's going to happen in 25. So how do we make this leap from looking at history and then going on into the future? This leap is possible by analyzing the trends of the past, which is what analytics is, but now with a view of extrapolating that trend into the future. This is what the basic artificial intelligence looks like. So here's the formal definition for you. Artificial intelligence essentially is software that can imitate human capabilities. One that I've already told you, that's the first point, which is predicting outcomes based on the patterns of or the patterns that have been observed from historical data. So observe the trend, extrapolate it. But that's probably short selling AI a little bit. Now that we're talking about AI, these are some other things we can do. We can recognize abnormal behaviors, events, making decisions or acting on them so that we can figure out how to, I would say, preempt these events even before they happen. There is visual input that you can interpret. So when I say visual input, I mean, if you have a video and you have a picture, you want to make a sense of what that picture is about or what that video is about, AI can do this for you. You're seeing, I would say, a sub-segment of that capability in the captions. I am saying something and it's getting translated into text. And if I wanted to put out the subtitles in another language, for example, French, I could do that right up front. So I'm speaking in English, the subtitles would go out in French, and you can take it one step further to say, if I'm speaking in English, the transcription or people, language or learners who are in French or who understand French would be actually hearing me in French. And this is not a far-fetched thought, it's already implemented thanks to AI. Finally, there is extracting information from sources. While this may seem very trivial, it's quite a powerful tool to have today, especially in the human resources world, because in human resources, we have epitomes of policies that we have created. And these policies are very difficult for anyone to go through at any point in time. What artificial intelligence allows you to do is to extract the relevant information from maybe a 200-word page document, not word, page document, and focus on the specific piece that you want information on. So let's say you want to know about parental leaves, and maybe you also want to know not just parental leave. Parental would include both husband and the wife. Let's say you want to know how many leaves is a husband eligible for in your organization out of that 200-page HR policy document that you have. With the help of artificial intelligence, you can actually extract that piece of information from that 200-page document. And then there are better ways of having that conversation with the humans as well. But some common artificial intelligence workloads that you will come across is going to be machine learning. And our talk is about how all these are related. So we'll talk about this. Machine learning is essentially that predictive model that we build. The first use case I talked about, where we looked at the history, and then we're trying to take that history or learnings from the history and move it forward in the future. There is anomaly detection in terms of detecting unusual patterns or events. For example, you have employees who are, let's say, taking leaves in a certain way, or their check-in and check-out times. You can apply anomaly detection on it. And maybe you are able to figure out if any employee has an anonymous login or check into the company or check out from the company, thereby only escalating anomalies that should be looked at. Today, the only rule that we have is you check in at 9 a.m. and you check out at 5 p.m. But maybe in the field, your 9 a.m. to 5 p.m. doesn't work. You may have a supervisor who checks in at 12 because he's in the field, and then already checks out at maybe 8 out of the office. And he does that on a Wednesday and a Friday only. Or the other days, he's not there. Now, for an HR manager to make sense of this behavior is quite difficult if you have a few 100,000 people in your organizations. For one or two, yes, I can understand HR people are able to handle it, or humanly it's possible. But when you think about hundreds of people, thousands of people in the organization, machine learning can detect if this is a normal behavior, or if the checkout behavior or a check-in and a checkout behavior is something that is something that is not, I would say, relevant, or something that is out of the ordinary. You've got computer vision, you've got natural language processing, and then you've got knowledge mining that I've already talked about. Vision, as I've said, takes inputs from cameras, images. You've already seen attendance now being done with the help of computer vision. So instead of, you're swiping your card or putting in your attendance card in that time machine, you can simply stand in front, or with the fingerprint, you can just stand in front of the camera and it automatically does that for you. In fact, if you have tens of people walking through a gate, the camera is able to decipher all 10 of you in one shot and check you in or mark your attendance right up front, instead of you having to go through a line. Natural language processing, again, is about me speaking. You see, I'm speaking in a very natural tone, and I'm not pausing. I am proceeding as I would in any other place, and the machine is still able to take all my talk and convert it into subtitles with immense amount of accuracy. There is also knowledge mining that I've already talked about. Sorry. Is there a question or something? Okay, no worries. So knowledge mining is knowledge mining I've already talked about, is about extracting information from a bunch of really large text format documents. Okay, let's move on slightly quickly now. This is how I explain the interrelatedness of AI, deep learning, machine learning, and all the other allied learning systems. AI is the, and the analogy that is here is that of a Russian nested doll. Right? So artificial intelligence is that outer shell, if you will. So it contains all, or AI is a generic term that encompasses deep learning, machine learning, and everything else. You open up the first layer and out comes another doll, which we call as the machine learning. Now, machine learning is still a further, or has further components inside it. You open up the machine learning component, out comes the neural networks. Neural networks, again, you open up and it comes out deep learning as well. So as you can see, each is a part of the whole being the artificial intelligence. Now, within this classification, you can also think of deep learning and machine learning in another fashion. And this is indicated by a Venn diagram. If I can sort of quickly build that up for you. If you think about it, and it just reinforces the thing that I said, This is the large outer circle of AI. Now, within AI, you have the ambit of machine learning. And another way of looking at it is probably not a subset of machine learning, but also deep learning, which is actually another way of running the models, or building the models up. Now, apart from the difference or the methodology with which the machine learning and deep learning is built, machine learning basically relies on statistics. This is closest to what we discussed about building up trends. So this is what is all trend based. So if you work with statistics and you know the mean median mode, y is equal to mx plus c, well, you're very comfortable already in the statistics space. And this is what takes the or sort of forecasting into the future is done using the same tools. So that's machine learning. But then when you come to deep learning specifically, and if I'm talking like a purist at this time, deep learning does not really use statistics. It actually uses what is called as a neuron-based learning to build up a model which is based off layers of neuron. This sort of learning is not quite statistics-based, and it sort of acts like a black box. It gives you what you require, but it does not really tell you how you built it. And that's where the responsible AI comes into the picture. Here with statistics and machine learning, it's quite clear what you are building. Y is equal to mx plus c clearly has what is m, what is c defined, which gives you the y value. But with neurons and deep learning, this is not very clear. It's not built on y is equal to mx plus c, but it is built on layers of neurons, sort of mimicking what a human brain looks like. That's why the name neural networks come into place. So as we go on, we'll talk about a little bit more. I also want to be cognizant of the time. So machine learning is where you kind of go ahead and create predictive models. What you see here in the graphic is kind of we take different pieces of or different images of flowers, and we let machine decide what flower it is after we have done an initial bit of training for the machine. So initially we take some data, we tell the machine, well, this is a rose, this is a sunflower. And then later on, after the machine model is trained, we bring up a new flower and ask the machine, can you tell me what this flower is? And based on the learning that we have provided or the training we have provided earlier, this is where it sort of becomes intelligent enough to tell you whether it is a rose and a sunflower. Now, this sort of, I would say, self-learning in some fashion is quite interesting when we get into domains where knowledge is still being evolved. Because here you're letting a person learn, or the machine learn by itself after you have trained them to a certain degree. You're letting the machine understand and interpret what is in front of it. There are different kinds of machine learning, supervised, unsupervised, depending on the amount of data that you have, the training data that we talked about. You may either be able to do supervised learning, or you, if you have very, very limited data, you may be able to do some unsupervised learning as well. Also, unsupervised learning has specific use cases in mind, specifically when the training data is unlabeled, which means the training data is not very clear on what is what. And this is where machine learning algorithms come into play. For each of these use cases where you have regression or classification, the machine learning is able to do specific points or guess specific numeric values, which is regression, or able to give you a classification or a categorization when you work with the classification algorithms. I just wanted to build upon a few more applications of AI, and we are now, instead of talking about machine learning, we are now in the space of deep learning, where vision is the use case in mind. Now, vision use cases or sound use cases, or when we talked about mining of data for specific things, this is where a deep learning has been found to be of immense use, or has been found to be much more accurate as compared to our traditional machine learning, which is based on trends. Here, as we said, the deep learning or neural networks are based um, on neurons and building layers and layers of neurons that actually learn very little. But by layering them up, they can actually build up an immense amount of knowledge within those layers. So the first example is that of image classification. It can look at an image and tell you what kind of object it is. You're kind of looking at object detection, which is another use case where it is able to, from a picture, tell you whether there is a bus, whether there's a car, and you also see some cyclists. Now, today you have a lot of cars that are coming into picture, which have ADAS implemented. And this ADAS systems essentially basically work on this object detection at the first level. They have to first detect if there is a person in front of them, and then the brakes are applied if they guess that, or if they know that there is something in front of them, or if there is an object for which they need to pause. Now, semantic segmentation, they sort of are an advanced kinds of model that can classify individual pixels on which object they belong to. I'll move on. You can look at image analysis, where you throw in a picture and artificial intelligence is able to actually caption the picture with whatever is contained in the picture. So in this picture, you can see it is labeled as a person with a dog on a street. While this may seem very trivial at first go, imagine you being able to now classify your entire set of image repository and do a search on it. So if I have an image repository contained of thousands of images, and I wanted to figure out which images have a picture of a dog in that, today it is possible by running an AI model on all of these images. Face detection and recognition, we've already talked about attendance systems being used to recognize who the employee is. And as you can see, there are a few people walking by, and the AI system is not only able to do this linearly, like one person at a time, but in a group of, here there are 6 people in this image, it's able to check in 6 people at the same time. And of course, OCR that has existed for a long, long time is taken to a next level by the help of the deep learning models that are there. I just put in some applications in recruitment for HR, that is recruitment, chatbots, and boosted learning and development programs. Now, most importantly, I think amongst all of this is this AI-backed chatbots. Chatbots are quite interesting in the HR field and have found a very, very, I would say, a lot of acceptance, because they can converse with people in their comfortable conversation tones. I can have a speech conversation, or I can write any text, and you know how people write their text, which is quite different every time because they're trying to write it in a conversational format. The chatbot is able to take that context and then deliver to them the response based on this context. So AI-backed chatbots are, I think, very powerful applications that you can find in HR today. Another quite powerful tool that is, or system that's extensively used relates to recruitment processes as well. All right, I know I've probably run out of my time, but I just wanted to leave you with the responsible AI. Now, while we are letting machines take care of a lot of things for us, it opens up another set of challenges. These are listed here. Number one is fairness. Um, you create a machine learning model for a loan approval, for example, and here the machine learning model may learn to distinguish between people based on, let's say, their age, their gender, their ethnicity, and so on and so forth. So the models have to be fair as well, and we have to take care that they don't start, I would say, acting against a particular subset of people. So this is quite important. This is one of those cases where it's a catch-22. Maybe you have a section of people, let's say based on gender, for example, which have a better rate of repayment of loans. The model will take a look at it and say, hey, you know what, if you're of a particular gender, then you have a better rate of paying back. But if you look at the law, it says really you can't distinguish based on gender. So should AI be actually doing this? Or you should be at least aware of what goes on and take appropriate steps to mitigate it if it is in there. It should also perform reliably. Errors in AI may cause harm, but AI is a probabilistic model. So we have to account for errors as well. Privacy and security is also quite important. Because we work with a lot of data to train the model, we should take care that privacy of individuals is not compromised. So data from Abhishek should not be expressed as data from Abhishek, but data can be generalized. So it can say male, 43 years of age, of particular caste, particular color, brown, of particular ethnicity, Asian or Indian, but not Abhishek. So sort of that's something that you need to take care. It should be inclusive. It should be transparent. I told you deep learning models have that problem where they act like a black box. So you really do not know what machine understood. There have been ample cases around the globe where machines were trained, or we thought we were training on something, and it ultimately turns out they got trained on something else. You've got accountability, and then which means whenever AI takes decision, who's to be liable for it, right? You may say a machine has taken a decision. I don't know anything about it, but then how do we fix the liability for these decisions that are taken up by the machine? So these are some of the principles that we have to keep in mind when we're thinking about the AI as well. Well, I will stop here. I know I've run out of my time. So thank you so much, everyone, for giving me this opportunity to speak. I will open up time for some questions. I spoke for about 30 minutes. Hopefully, this has opened up some thoughts in your mind. What I would do is, based on your questions, I will then develop that particular concept as well. So if there are any questions that anybody has in mind.
Abhishek, I think I'm the person who is mesmerized, but still, I want you to help me in developing this university, and I've got two, three things in my mind. One that suppose people are working from home and they are claiming that they are working for the university, and exactly I don't know whether they are working for university or they are going for cyber loafing.
All right.
Second one, you told that can AI be used for unlearning also, because people in most of the cases are having learning and it becomes a bias. For example, I've heard people telling I'm electrical engineer, I don't know HR, or I'm a finance guy, I don't know what is engineering. These days, this is so. Can AI help me in unlearning also, except deleting the data? Third question is that someone I was given, rather I am not very sure about it, whether the information is correct or not. but the company Intel is trying to um, develop a chip where they could write the configuration by which, if it could be used as if it were a headphone, and without telling anything, if an idea crosses my mind, then machine will start working accordingly. For example, if I tell Alexa, remove the curtain without using voice, will Alexa be able to do it or not? So
All right.
these three things I had in my mind. I thought, let me steal your time and then get the credit for my university. And before I allow other participants to put forth their questions and concerns.
Great, thank you. As I said, I spoke for 30 minutes. The idea was to get what is on your mind and then respond to it. So this is a great, jumping point for me as well. All right, so the first one was work from home and whether people are really working or they are not there, or they're doing something else. Now, in terms of AI, we need to figure out, well, so the first set of the first set is you've got, thousands of people use different applications all the time, and you can't really monitor 1,000 people at the same time. So where does AI come in and how does it help? Number one, when you think about work from home, number one, obviously the simplest of it is how much time does a person spend in front of the camera? So if I'm sitting in front of my camera, so out of 8 hours, if I have to say, I have to almost spend, let's say 4 hours, and 4 hours is a random number. This number will come up again from AI, which means the AI will be able to look at your video. And when I say your, I mean thousands of streams that are coming in, and will be able to analyze for each stream. Let's say out of 8 hours, a person was there in the camera for 4 hours. So that gives you the first point of reference. But the second point of reference is what application is the user using on their machine. Once again, a person who's in R&D may spend a lot more time looking on the internet. A person who's from operations need to be probably spending a lot of time on ERP system. Another person who's from HR may be looking at Word documents. And so what is the correct use will again come out of the profile of the person. So once again, we'd have to define personas, which is the standard way of doing things. You define a persona of a person, and then you say, okay, we'll kind of let it run for a month or two where we just gather data. Okay, an HR person, an operations person, a finance person, how are they spending time? How much time are they spending in front of the camera? What is the kind of application they are working on? This gives you a reference built by AI or benchmark built by AI. And then on a day-to-day basis, AI can figure out if the levels of tolerance have been exceeded. Now, again, what is the level of tolerance? AI can give this for you. And specifically, the kind of tool that you will use here is again anomaly detection. So you will set a standard for each of these profiles, and anybody deviating from this is going to be an anomaly. Now, how is it better? Well, in older systems, you had to define, let's say 5% deviation, 10% deviation and such. In anomaly detection system.
For a moment, when we were taught statistics, then we were told about the outlier concept. Is it something like that?
Pretty much, yes. But what I'm explaining is how we apply that outlier concept in work from home.
Sorry, yeah, please go ahead.
Right. So in work from home, you can figure out whether we need to give a tolerance of 5%, 10%, 16%. That machine can also be geared to answer. That, I think, explains what I would do if I was to develop a work from home system. The second you talked about was unlearning and the biases that people come with. Well, I think machine learning may not be really a system that helps with the way you explain if there is a finance person or something of that nature. But if I take you to the, or when I talked about applications in HR, you take a look at this boosted learning and development programs.
Yeah.
Now, here you have personalizing the learning journey. If somebody from the finance has to be presented with what is the extra thing that they can learn, which means recommendations based on relevancy of their jobs. We may develop a huge knowledge repository of documents, trainings that are video based, audio based and such, but then what to offer to whom is the problem comes up. And once again, with AI, you can match these personas, and the personas can then be recommended based on extracting keywords from videos, audio, pictures, and then that content be offered to them proactively. If they are searching for some information, again, AI can be brought in to make a recommendation saying, well, this is your profile, this is how we feel you can learn. Again, this can distinguish between a beginner, mid-career, or a senior person and appropriately offer the learning program. The third piece you said about a thought-based AI or whatever, which Intel is developing, well, I would say that's still a little far out. We can talk about it, but I don't think we have a real use case for it now.
I'm not sure about the reliability or validity of the information, because it was given to me by somebody who is not working with Intel. Might be a competitor, I don't know.
That's all right. So as I said, there have been experiments in how we can interpret our brain waves. So when we think cat, there is a certain brain wave that goes out. Similarly, when you think cat, certain brain waves go out, and everybody, when they kind of think of cat, different brain waves go out. So if you're able to develop intelligence around what brain waves equate to cat, then maybe one day we'll be able to get there. For now, I would say AI is still in the enablement phase for the thought-based processing, but not yet there, reliably at least at this point in time, or at least I don't know of any such system being in place.
No, Abhishek, your global persona, I couldn't find out today, because I, as a person who is making others understand, I have seen you in another domain, I mean, live on TV and answering the questions, participating in debate. I remember walking the dog and talking to me, all these things. But then today I found global persona, Abhishek. Believe me, I don't have any reason to flatter or praise you. This is the reality. And the number of questions I was getting from the participants on the screen, I have noted down. They are telling, sir, just seek his permission whether you have recorded the lecture or not. I told, yes, I have recorded. Now someone is requesting me from UK that can I pass it on to her, because I did not allow participants to record it. I mean, I believe they did not, but then I don't know who is doing what. People with better algorithms may do. So for a moment, I am inviting the participants. If anyone wants to directly interact with Mr. Abhishek Kant, one can do it. Or else, I know how precious time he has stolen for my university, and that too a university which is still in its infancy. But then, really, I'm mesmerized today, Abhishek.
No worries. Any questions? I appreciate your thoughts, Dr. Pandey. I appreciate them hugely. Any other questions that anybody has?
Yeah, someone has asked a question on, I mean, I don't know why she is so timid, but she has asked me that I should tell her as whether she should go for natural language processing program run by Stanford or maybe some other university. I think I'm not aware, and I don't know whether you can offer a piece of advice to her.
Sure. Yeah. Well, natural language processing is obviously a field which is most amenable for deployment of AI, because that's what we do all the while. Whether it is speech or whether it is written text, natural language processing is quite important in both these scenarios. So if you think about natural language processing, this is both from terms of speech to text, as well as speech synthesis, which is take text and convert it into speech. If you take it one level further, natural language processing goes on to say, can we generate machine-based sentences as well? So all of these are very, very relevant for us right today. This is nothing in future. This is today. So if you're interested and if you are, I would say, excited by these technologies, then please go ahead and take those courses. They would definitely help you set this up. What I can say about natural language processing is simply the fact that it's something that's immediately relevant for all of us. And I've told you about speech to text. I've told you about speech synthesis. I've told you about natural language context interpretation, wherein if I'm saying something, what do I mean? What is the context of this conversation or intent of this conversation? What is it that I want? And it can be said in different ways. So how do you interpret that? Finally, the epitome of speech or text or natural language is speech generation itself, where the machine is able to generate speech for you and write an entire book, if you will, which would be slight exaggeration, but at least generate some text for you.
I mean, frankly speaking, I had read a book maybe a couple of years back, Work Without Jobs. So today I found that probably I am working without jobs. And will you permit me to share your lecture that I have recorded in my personal capacity with other participants subsequently, or should I not?
Yeah, that's all right. Please do share. It's absolutely fine.
Yeah. So Abhishek, I am really thankful to you on behalf of the participants. Someone is sending me a picture where in Japanese style they are doing this to you. Someone is doing this, and they are using many emojis. I'm really very, very thankful on behalf of the participants. More so, I'm thankful to you on behalf of the entire fraternity of World University, though it's in an infancy. And I look the guiding star of the university in future in this domain. God willing, university at this stage cannot pay any pecuniary remuneration, but then a letter of commendation is well deserved. Thank you so much for sparing your time, Abhishek. I'm personally indebted to you. Thank you so much. Have a great day.
Okay. Thank you so much as well. Yeah. Bye-bye. And anybody has any questions further, you can definitely drop me a line. I'll be happy to answer that. My email is mentioned once again at the top right of this slide.
But then I'll get it routed through me. Otherwise, it will be overwhelming for you, Abhishek. So sure. Let me be the gatekeeper there.
Sure, absolutely. Thank you.
Thank you so much once again.
Okay, bye-bye.
Bye-bye.